Good morning, everyone. Today we are going to introduce the second part of this lesson, inverse function. And as I mentioned, this topic has many parts to discuss, so that's why we're going to spend several days to discuss this topic. So let's get started. Let's check the first warm-up. So this warm-up tells us find the inverse of each function table. So as we discussed yesterday about this lesson, inverse simple words is just reverse x and y input output. So the input output, the position is actually are going to be changed. So for the first one, all we need to do, we just need to change the position of both. And again, no matter how do we represent function, we still prefer x to represent input, or we say domain. And so for inverse, we use f of inverse. We use this symbol, but remember this x is different from this x. Okay, now let's check this one. We do the same. We do the same thing, and we are going to draw the table, and we are going to switch the police for each one. Again, we just use a new notation to represent this one. Now, after this one, I want you to look closely for these two tables. Before each one are function table, because we need to check if x is repeating, which is not. That means this function table, this table are functions. Now let's check the the answer for the inverse. So if you check the first one, we notice for the input 4, we have two different output matched to that. So this is not a function. Let's check this one. This one is fine because every single one is different. So that's why this is going to be a function table. So it seems that after we find the inverse of original function, and sometimes its inverse is not function anymore. So today's focus is actually what kind of function its inverse is still a function. So inverse of a function is still function is actually limited. It's not all the function whose inverse are still function. So that will be the focus today. Now, so what kind of function is actually its inverse also a function? Let's check the difference between these two. As you can see, every single x is different for this, and every single y is also different. For this, every single x is different, but every single y is not different. So that's a bigger difference between these two functions that lead to the result the inverse is not a function for the first one. So we call, when x and y are both different, we call this kind of function our one-to-one function. And only a one-to-one function can have whose inverse is also a function. And also, do not make it complicated. So one-to-one function is one special type of function. This type of function, the very big feature for this one is x, y are unique, meaning we have different input, you have different output. So, for example, let's check this example here. Every single value for the x has one y to match it. And for this one, as you can see, x, the input is 0, 1, 2, 3, 4, all different, and output is also different. However, for this one, the reason this is not a one-to-one function, as you can see for input 2 and 4, they have same values here. So this one is a function, but it's not one-to-one function. So that's a difference between this one. Now, let's check these choices here to see if you can find which one is a one-to-one function. Check each table, which one represents one-to-one function. So you can pause the video here and check which one is one-to-one function. And the very first thing when we do that is first there has to be a function, meaning x cannot repeat. So when I say x repeat, this is not a function, not a function. And if I check this one, it seems that every single x is different, but I do have same y here. So it is a function, but not one-to-one. Let's check this one. 1, 2, 3, 4, 2, 4, 8, 16. So everything here, x is different, y is different. So this one is a function and one-to-one function. Now let's check this one. I have input -2, match to this one, two different values. So this is not even a function. So that's how do we do that. And the very last thing I just want to share with you, the inverse of one-to-one function is also a function. So that's why we have to mention one-to-one function here, because it's a special feature leading to its inverse also function. So in next video, we are going to look at the different examples to reinforce our understanding for one-to-one function. See you soon for next video.